Thank you for attending this day. I think a lot of interesting inspirations here. My name is Jens. I'm the solutions director at Sereact. Sereact is a company from Stuttgart, from the Ländle, South Germany, founded 4 years ago out of the university by two robotics and programming PhDs. I was the first client in the past, which was quite funny, 3.5 years ago. And we are focusing on AI robotics in, actually, mainly, I would say, in logistics environments. We have also some industrial clients, but more on that. But the first and most important thing is for us, because the question also was raised in the panel before, for us, everything that we are doing is AI. So we not decide between some traditional ways of controlling robots or not. We use every time AI. So I would talk a little bit about effortless automation, pick and place with natural language control, which is, I think, really impressive. I have a demo in like half an hour with a huge client here where we also started talking with the robot on items that we never saw before that we will bring to our office here. But let me give you just an impression how it looks like. Yeah, we have here on the right side, my dear colleague give this robot, in this case a UR10, the information, please pick this order, yeah, via language or via written language, so a prompt. And what the AI makes is not only transferring this, I would say, a spoken task to a physical task. What the AI is doing is to understand sequences, understand subtasks, and understand how to actually provide a solution in a specific situation, which means here the AI looks at the source bin, detects multiple items, understood that there is a target bin with a different size and footprint, starts to pick and place, so do the pick and place and also the packaging identification on the fly, not calculated before, picks the items and place the items without knowing the dimensions of the item, without knowing the weight of the item, without being trained with machine learning on the item. And as you saw, there also built a sequence where the AI thinks, okay, this kind of items are more delicate. I should pick them later. Yeah, this is just a showcase to show, okay, out of one simple task, and this could also be an information stream from a WMS or WCS, there is a lot of thinking that the robot does beside and behind, yeah, to fulfill the order, the task in the best way in this situation the robot and the AI sees there. How does stuff like this looks in reality? Here on the left side, we have one of our client sites, and I want to emphasize shortly on what you see here. This is a completely different robot. Yeah, it's not a cobot, it's an industrial robot, it's a Yaskawa, it's a different size, different speed, and so on. Our AI works on all the main robot companies and also on all the main robot types. For the client, it's a cell and a functionality that he or she is buying. We decide on the AI in a project, this is feasible for the AI, this not, and then we design the hardware around. And here I came to the next point. This one, for example, is a gripper that is patented from us and designed by us and also partially produced by us. And this is only one of the grippers that we build by our own. So we use hardware as tools, yeah, and not as a limitation or something that defines the parameters of a project. So here you can see items that we place in a really dense situation. So we empty, nearly empty source bins and then dense it to give the auto store, in this case, more air to breathe, right? So more empty bins. And here at this point, Alexander told it in the discussion before, he said, with 10 or 20 items, it's easy to program it from 800 to 1,000 items. He is using AI. At this client, we have 2.5 million different SKUs, not items, but different SKUs. And If you just imagine no real product data, no product pictures, nothing around that, no rate in the system, and we just look at the items and then decide it will fit there or it will not fit. And this is something you cannot fake with 2.5 million SKUs. I just calculated once with one of our competitors, which uses machine learning, and this company would need 5,700 years to do this case with machine learning. Yeah. And what is also really interesting and highly, I think, yeah, highly impressive is the AI also detects different kind of shapes of articles and also which kind of material it is. You saw here before that when it's, for example, carton, the AI really avoids collidates, yeah, and against the walls of the bin. When it sees polybag, the AI knows, okay, it's a polybag. Opala, sorry for that. I will go back. It knows it's a polybag, so I can put it a little bit more also to the edges, because a polybag has not a fixed size and a fixed structure of the entire package. Yeah, and this is also not something that we get from the WMS or in Excel list or Excel sheet or something like that. This is what the AI decides exactly in the situation where it needs to be decided. So I will continue. So what is actually, to sum up, the unique skills of our software and of our products? So the first thing is we can, yeah, you mentioned it in the beginning, we don't program the robot, we can adjust it to situations, right? And this is quite important, not to tell the robot, hey, pick this item, or hey, pick this order. This is important when you're in a chaotic and highly uncertain environment like a warehouse is. You got changes in the material flow. And if you got changes in material flow, the normal procedure would be the people who know the changes will translate it to the IT department. The IT department will look what is possible, will discuss it with the people that owns the process, and maybe weeks or months later, you have your change. What we can do and already also do at our clients is that the person that really sees the need for adjustment or really sees the problem why the material flow has to be adjusted can go to the robot and write it to the robot or speak to the robot in natural language without predefined words, yeah, and also different languages. We already use it at clients with Hungarian language, Polish language, Czech language, German language, Dutch, and so on and so on. So the person who really sees the problem can go to his colleague, the robot, and tells, please do it this way and not this way anymore. For example, here was the situation, yeah, we got more and more dust and dirt and also rubbish in bins at that client. So the persons on site tell the robot, if you detect this kind of dust, trash, or whatever, please send it to a cleaning station. Yeah. Next thing is zero-shot reasoning. Yeah, this is really important. I will show one short picture on that later. We are not training or machine learn on items. We put the robot on the side, integrated into the WMS system or the other subsystems, build a defense or the safety equipment around, and then it starts. Yeah, and then it starts from day one. And then it also picks from day one. So there is no need to do a long project with learning specific items or programming on specific items. Last thing is, and this I really also like, it's a picture from this year Logimat, where we had an open demonstrator. So everybody was allowed to join and just throw stuff in the bin and we then pick it. And one attendee of the fair throws in these Pringle boxes. They came not from us, yeah. And one of the Pringle boxes he crushed. And then he asked the robot if he can please select anomalies in the bin. And the AI was able, without trained, or maybe also never saw this kind of Pringle boxes before, to detect grip and then also update it to detect grip the anomaly, so this destroyed Pringles box, and then also update the amount of still sellable items in the box. So a lot of information, a lot of data are processed, and the end information is then sent to the WMS. All this together, and that's where I switched for a second because I want to show you also something from real world. This is a client dashboard where we started on the 14th of October, first day of picking, first day of integration testing. Today we have the 5th of December. And what we see here is first day, that's what I meant with zero shot reasoning. 60%, 20 test picks. Day after, 89%. And since then, we are more or less always above 95%. And when you look at the situation and the kind of items in the bin, there are some easy stuff, there are some less easy stuff, and none of them was known before or trade. Yeah, for example, this is a nice example. Quite hard to don't do double picks, right? And this, what you can also see, this is a really good example for AI. We have their mixed bins, yeah, or compartments that not really stick to the bin. And if you don't use AI, you cannot do anything with stuff like that. And we got a lot of this. What we are doing, we get the name of the product from the WMS and check which of the items that are available in the compartment or the bin is most likely that one that is described in the article name. So we don't compare picture, we compare text with situation in the bin. I will go back. Here we go again. Last but not least, I want to show you one product that we started now on. Actually, one of my babies this year. I really love it. It's we understood that we could find a lot of data and information while robot picking. But it's also like that. A lot of these information are also needed in different parts of the material flow where you not necessarily need a robot. So what we do is we put on, as you saw it here at the beginning, one of our cameras above some interesting locations in the warehouse and on the material flow, and collect data and create information with the AI out of that. For example, anomalies, yes, stock problems. We control at one client the outbound carton if the right item is in there. We just signed a contract with a pharmacy company, or are on the way to signing a contract with a pharmacy company where we check if it's really the right medicine articles that were sent out to the clients, yeah, while with identifying text, amount of items inside, regarding the shape of the items, also regarding the size of the items, to detect really if this is the right thing that went out from the warehouse. And what we also do compared to our robot, I will just go a little bit further, is that while doing robotic situations, yeah, we have our dashboard here, have all this stuff information beside it. And in this client, we put one of our lenses in the inbound also, where we then looked at every item that goes into the warehouse. And I will just stop for a second and just identify what we are seeing to also identify, is it the right thing? Is for the right items, the right documents inside? Does it look like the right items from the shape and from the amount? And then if anomalies are detected, send it then to the clearing before you have the problem in your stock. Yeah. So this is also a use case for our lens beside and together with a robotic cell, for example. Yes, that should be all for now. Thank you for having me here, and thanks a lot for listening to my short presentation.
Great presentation. I'm quite sure there have to be questions about this new technology. And the first question is great. Can your system handle accents or different languages in voice commands? As
Ah,
you mentioned, you're from Stuttgart.
I'm actually half Danish and from North Germany, but yeah, we also have a lot of accents there. Good point. Not perfectly, no. But to be honest, this topic with speech, yeah, with speaking, with voice speaking, is more or less something that is possible and also a nice thing for showcases and demos. In a warehouse, you will just type in. Yeah, it's too noisy. Yeah, mostly it's too noisy. So you will do it with written language. And there you can also write with accents. And I can tell you that Schwäbisch, yeah, can be understood by our robot. I'm not sure if every accent in the world could be understood, but Schwäbisch is possible. Yeah.
Next questions. How long does it take to get the system operational from installation to execution?
Yeah. For example, what I showed you in the dashboard, the very first day was not the first day after SAT. It was the first day where we test the integration to the WMS before the SAT. So when we did the SAT, which was more, I think, 4 days after the integration test, after the SAT, we were at 97% peak success rate with thousands and thousands and thousands and thousands of items. And the client all managed, I showed you 14th of October, he managed 3-shift operation with the robot at Black Friday.
And how does PickGPT integrate with existing warehouse systems or workflows?
Yeah, so PickGPT is more stuff to control the robot and to give the robot more AI power. So a lot of what we saw in my presentation is on site in an EPC, yeah, IPC, in an IPC. What is really difficult questions and needs more AI power is, for example, to identify from an article name the right article in a mixed bin. There we have a connection with PickGPT to our servers to give it the needed calculation power. Otherwise, you could stand there for 30, 40 seconds to get an answer. For this, you need power to get it really in time. Yeah, the integration is really easy. We have a standard API documentation, which is quite short. We have a lot of integration made with ERP systems also, but especially with WMS systems. With most of the integrators that are known in intralogistics, we already work together, either really together or we integrated by our own in their system at the site. And with some of them, we are also partnering. So we are aware of a lot of different kind of integration scenarios and also strategies.
And how fast can you normally pick with this technology, picks per hour?
Yeah, actually, the limitation is often, or actually always, not the robot, but the before material flow and the after material flow. For example, out at an auto store, the bin presentation limits. Yeah, at the shuttle system, the bin presentation limits, and so on and so on. But what we did so far, the fastest thing that we ever saw in our laboratory, not existing application, and definitely also will never be existing, was 2,100 picks per hour. What is possible in reality, what we saw so far from functionality to functionality, it always depends. For example, insertion in a sortation system is much faster when picking and placement in a shipping carton. There, the deviation is between 1,100 and close to 400, depending on the process, sub-process, and the flow before and after.
And how do you deal with possible collisions between robot trajectory and the bin?
Yeah, that's why we look with our AI always at the item and find out the dimensions by ourselves and also the shape of the item by ourselves. You saw it in the one video when we identify an item as a stable item, right? We will not collidate. If we collidate, what can happen out of some reasons, we let the item get off the gripper system, right? So in case, so we don't destroy anything around. But this is really rare. And for items that the AI identifies as a not stable item, it is allowed to collidate a little bit, to squeeze it and dense the placement better.
So Jens, thank you very, very much for this very interesting presentation. Totally new technology. I found it fascinating.
Maybe one sentence, because one last sentence. The technology, it's for me, it's really important. The AI system that we use, also the learning funnel, is our own. We are completely in charge of that. We are completely control it. It's not integration or a connection to something like OpenAI. It's really our model, which is, I think, really important to state that out.